we were talking about measures of dispersion, how spread out our data was, and we looked at range, standard deviation, and variance. So range we know is the highest minus lowest. Standard deviation, we talked about doing it by hand and on the calculator. Most of the time we'll do it on the calculator, but you have to be able to do it by hand. You should be expecting at least one on a quiz or test, so that's when we made that whole table. So you had to do each value minus the mean, square it, add them all up. And then the variance is just your standard deviation squared. So the last thing that we're going to look at in this, there are two rules that have to do with bell-shaped data. So bell-shaped, that's symmetric data, so it's not skewed. The first one is the empirical rule. And if you guys have your formula sheet handy, you will see this entire rule is on your formula sheet, so it's not like you have to memorize it all or anything. This only applies to bell-shaped data. So it tells us 68% of the data will be within one standard deviation of the mean. 95% will lie within two standard deviations, and 99.7% would lie within 3 standard deviations. So what that's saying is if I have a set of data, and let's say the mean is 25 and my standard deviation is 4. Okay, so the mean is 25. That would be the center of my data. It tells me 68% of my points should fall within one standard deviation. So one standard deviation would be if I subtracted 4 and added 4. So if I'm looking at my original data, I would expect 68% of those values to be something between 21 and 29. 2 standard deviations. So if I subtract it again, standard deviation was 4. So if I subtract 4 and add 4, so I would expect 95% of my points to be something between 17 and 33. Okay, third standard deviation. 13 and 37. So 99.7% of my points should be somewhere between 13 and 37. Does that make sense? We can kind of think in terms of percentages too. So if 68% is in the first standard deviation, then that means you would have 34% below, 34% above. If we think about the next group, from here to here is 95%, right? 68 is in the middle, so how much is left? You do 95 minus 68. 27, and you would have to split it over the 2 ends, so that means an additional 13.5% would be in those ranges. So I think that little picture that I had on your notes had these percentages, but that's where they're coming from. So within 3 standard deviations, we said 99.7. Okay, so that's an additional 4.7%. Okay, and that means the variance, if this is 99.7, there's only 0.3% left. So after the 13 here, we would expect 0.15 on each end. So if you're wondering where those percentages came from, it's just a matter of dividing the percentages in half, half above and half below. So let's look at a problem. This data gives cholesterol for 54 female patients of a family doctor. Determine the percentage of all patients that have cholesterol within 3 standard deviations of the mean. So here's a quick, I gave you this graph to verify, is it bell-shaped? Not perfect. Is it somewhat bell-shaped? Yes. So that means the empirical rule, since it's not perfectly bell-shaped, it may not be exact, but it should be close. Let's check. So if we want to actually find within 3 standard deviations, we need the mean and standard deviation, don't we? So go to your calculator, enter all of your 57.407. So let's just say, let's go ahead. Normally I would say more than one decimal place, but let's just keep it at 57.4. Just kind of help with our calculation a bit. All right, standard deviation. Do we have a population or a sample?
Oh.
It didn't necessarily state it one way or the other, but it said of the 54 female patients. So how would you interpret that? Do you think that's all of them or part of them? If it says of the 54 female patients he has, I would assume that's all. But of course that is kind of not perfectly clear. So if it's all, then it would be a population. So 11.696. So let's say 11.7. All right, so if we want to think within 3 standard deviations of the mean, right? It can be helpful if you're struggling at all on these to draw yourself a picture. So our center was 57.4, and a standard deviation was 11.7. So to get your standard deviation, you have to do 57.4 minus that. Okay. I'm going to go ahead and get all of these. I could just keep subtracting it. And then to get above, you would add your standard deviation. So 1 time, 2 times, 3 times. All right, so I want to know, we know the empirical rule says how much of the data should be within 3 standard deviations. The empirical rule says we expect 99.7%. Let's see how well it is. So we are basically finding how many of these were between 22.3 and 92.5. So how many of them don't fit in that window? Are there any? No, so it says 100%, so pretty accurate. Determine the percentage of all patients that have their cholesterol between 34 and 69.1 according to the empirical rule. Okay, so the empirical rule for this one said it should be 99.7. We did a quick check on our data, we had 100%. If I were just using the empirical rule, not even counting my actual patients, between 34 and 69.1. So 34, that's 2 standard deviations below, and this is 1 standard deviation above, right? So we know if we think about those percentages that I wrote up here, in the first standard deviation, you expect 34% above, 34% below. What percentage did we add in when I looked at that section? 13.5. So if you add all those together, what do you get? .5. So by the empirical rule, we would expect 81.5%. Let's see, how many did we actually have between 34 and 69.1? How many of them? Everybody should be counting points. I'm not the only one that can do it. How many did you find? You guys agree? Okay, so if we had 45 out of the 54 patients, that is 83.3%. So was it pretty close? Empirical rule says should have been 81.5. We had 83.3, so pretty reasonable. That means we probably have pretty more bell-shaped data than we realized initially by looking at that graph. All right. So the second piece is what if it's not bell-shaped data? And then we have to use what's called Chebyshev inequality. So this applies for any data set. You would expect to see 1 minus 1 over k squared % of the observations to lie within k standard deviations of the mean. So if you wanted, like within 5 standard deviations of the mean, your k would be 5. So k is the number of standard deviations. If we try this on a set of data. So using Chebyshev, determine the percentage of patients that have the cholesterol within 3 standard deviations of the mean. So it's 1 minus 1 over 3 squared. So that gives us 0.8889 or 88.89%. Notice it's not as high as the empirical rule because the empirical rule is assuming that all the data is kind of clumped towards the middle. And if it's not bell-shaped, we can't assume that, so it's going to be lower percentages than the other. If I asked you to find the actual number within 3 standard deviations, we already did that. And what did we find? Didn't we count 100% of them? So it's not going to match exactly, but it's a minimum. We would expect at least this many to work. All right. The last thing in this section, actually this is the only thing I'm covering out of section 3, is a weighted mean. So to find a weighted mean or a weighted average, this is how your GPAs are calculated. You take each value times its weight, add those up, and divide by the sum of your weights. So like if you think about your GPA, an A is worth 4 points, a B is worth 3 points, a C is worth 2 points. So to find your GPA for the semester, you take your number of A's times 4, plus your number of B's times 3, plus your number of C's times 2, add them all up and divide by your 7 classes. And that gives you your GPA for that point, or for that semester. So let's try one. Bob goes to the by the weight nut store and creates his own bridge mix. He combines 1 pound of raisins, 2 pounds of chocolate covered peanuts, and 1.5 pounds of cashews. Raisins cost $1.25 per pound. Chocolate covered peanuts are $3.25 per pound. Cashews cost $5.40 per pound. What is the cost per pound of this mix? All right, so to find it, we have to take each value times its weight. Okay, he had 1 pound of raisins, and how much do raisins cost? Add in, we have 2 pounds of chocolate covered peanuts, and those cost we have 1.5 pounds of cashews, and those cost divided by, okay, this is where people get confused sometimes, what should go on the denominator. And a good hint is to look right here. It's cost per pound. So that means the top of this fraction should be cost, and the bottom of this fraction should be total pounds. Okay, so my pounds would be 1 plus 2 plus 1.5. Does that make sense? Well, let's see what we get. Since we're talking about money, we'll go to decimal places. Did you guys get that?